Today we're going to be looking at special logarithms. Now, there are two logarithms that are called special types of logarithms. The first one we're going to go over is a common logarithm. A common logarithm has a base of 10, and anytime you have a common logarithm with a base of 10, sometimes you're going to see that it's imaginary. But you're going to have to remember that if there is not a base written, it really has that base of 10. Okay, that's very important. So let's take a look at example 1. If I ask you to rewrite log of 100 is equal to 2 into its exponential form, remember the first thing you circle is the base, the second thing you circle is your answer. Well, we don't have a base, so we would actually have to put our base back, and then we would circle our base and our answer. And whenever I rewrite it, I end up with the base of the exponential form to the exponent is equal to the argument. And you can see that this is a true statement because 10 squared is equal to 100. Let's take a look at example 2. On example 2, I'm trying to rewrite it into its exponential form. Well, I can see that my base is missing. I go ahead and write down my base of 10. I circle my base and my answer. And whenever I rewrite it, it becomes 10 to the negative 3 because it's our base to our exponent and it's equal to our argument. On example 3, I'm going to do the same thing. I'm trying to get it from its logarithmic form into its exponential form. I notice my base is missing. It has a base of 10, so I'm going to circle my base and my answer, and I'm going to go ahead and rewrite it so it is my base of my exponential form to my exponent, and it's equal to that answer, so 10,000. So 10 to the fourth is equal to 10,000. Let's take a look at example 4. This one says log, and our base is missing of 1/10 is equal to x. So I'm going to put my base of 10 back. I'm going to circle my base and my answer, and I'm going to go ahead and I'm going to rewrite this. So I end up with the base is 10 to my exponent is x is equal to that argument 1/10. Another special type of logarithm is something called the natural log. Now, I need you to make sure you know that natural log is the letters L in. And what the natural log is a logarithm with a base of e. Now, e is a number. It's called Euler's number, and it is something kind of like pi. Pi is the most common that you've heard of, but Euler found this number occurs very often, sometimes in patterns of nature, but always when they're in the pattern of growth. I'll link a video in our notes so you can see how base of E was found. I thought it was pretty interesting. Let's take a look at example 5. So if I had the natural log, that's what you say, the natural log of 2.389 is approximately 2. What we would do is we would say anytime it's got the ln for natural log, it really has an imaginary base of e. And so now I can circle my base of e with my answer of 2, and I can say e to the second is approximately, that's what squiggly lines mean, approximately 7.389. And now I've rewritten it into its exponential form. Let's look at example 6. I have the natural log of x is approximately -3. So I can say, okay, we're going to rewrite our base. Since it's missing, we're going to write our base of e. I'm going to circle my base of e with my answer. And I'm going to say that e to the -3 is approximately x. Now I'm going to look at example 7. Same thing. I have the natural log 54 and 598 thousandths is approximately 4. So I'm going to write my e as my base. I'm going to circle my base and my answer. And whenever I rewrite this, I have e to the 4th, approximately 54, and 598 thousandths. Let's look at example 8. Same thing. I have the natural log of 1/10 is approximately x. I'm going to put my e here. I'm going to circle my base and my answer. And whenever I rewrite it, I get e to the x is approximately 1/10. Thanks for watching, guys. Now you know the two special types of logarithms that we have. common log, and the natural log.